So good evening, everyone. Welcome back to Plan 252, okay, transportation modeling. um, okay, so today we'll discuss about a part of traditional transportation planning. We last time we already discussed growth factor and partially linear regression, right? So and also partially nonlinear regression, but we haven't finished this part. Uh, Let's continue. Okay, today we will discuss about this regression, which is part of actually trip generation. Okay, uh, you can go to the model in Refleto, okay, and then you can follow this in the slide about what? Okay. Traditional transportation planning. Okay. And you can download this slide. Okay. And of course, if you will need the text aside from the slide, okay, you can go to this link. These two links is about regression tutorial and nonlinear regression tutorial. Yeah, and you also have this assignment. Okay, to do this using matrix. Yeah. So, and next week we have a midterm exam. Okay. So the midterm exam is online here in Revoledo from 6 a.m. to 6 p.m. After that, we have class as usual from 6 to 9. Okay. Because we have missing class last time during public holiday. Okay. So this is similar to the quiz last time. Hmm, what is that? In required two model. Okay. So yes, two model. One is using population. The other one is vehicle. Yeah, for the assignment. Yeah. So if you cannot find the in your province, okay, or in your city, so you can use the one that available. So this is just practice. Okay? The data itself is not that important. Okay, so let's start with yes, June, you want to ask something?
Yes, sir, about the midterm exam, the coverage, is it more about the concept and terms like,
Uh, no, there are many calculation inside. Yeah.
oh, any calculation?
Yes. Yeah. So there are many calculation inside. So from beginning until today, yeah, including the regression. Yeah. So it's not just concept. Okay. So you better prepare and practice before the exam. Okay. Of course, because exam is multiple choice and online. Okay. So you need to be careful because uh, sometimes you must select all possible correct answer. Okay. So if you answer incorrectly, okay, or you did not select uh, some of this possible correct answer, of course you will get negative mark. Yeah. So, but negative marking is only minus 10%, so there's no problem with that. Is it clear, or do you have any other question regarding the midterm? So if not, let's go to the slide of regression. Okay. Last week, okay, we discussed about regression, linear regression, right? This spot. Can you see the slide? Okay. So last meeting, we discussed about linear regression, and then at the end of the lesson, we discussed about nonlinear transformation. Okay, so let's start with this simple model at the beginning, maybe this one. Okay, so in that case, I will use Word. So I will use the Word. Can you see my word processor here? So we have our model is y equal to a times x exponent b. Okay. So suppose this is our model. Okay. So then what you will do is to take the logarithmic log of y equal to log of this one, right? So this is the right-hand side. Okay. And then what you will do is now this part, okay, you can expand. Okay. So in that case, I will copy this. So in this case, you have log A, right? Log A plus log of all of this, right? Log of all of this, right? And then you can also expand back here because this is exponent, so you can put it be multiplied by log x. Okay, so now you can create a substitution, for example, x, small x here. Let me make it small x equal, small y. Small y equal to this part, the left-hand side. Okay, and then now we have, say, we call it alpha equal to log x, log a. And then now we have beta equal to b. And then this one, okay, now small x equal to log x. So this is the transformation that we want. Okay. Then if you have that, what will happen? You will have y equal to alpha plus beta times small x. So with this linear model, this part, right? So this is a linear model. You see that? So what you will do is now you have the data, which is initially this capital X and Y, okay, and then now you transform into this transformation, okay, to become linear. So in that case, now you create a new table with this small x and small y, and then you get the slope, this one, and the intercept. Yeah. So in that case, you will get a linear model. After you finish, okay, you return beta is the same as B, and then alpha is the same as log A. So if you want to get the A, okay, now depending on the log that you use, okay, so now the base of the log, for example, if your base is 10, then you will have 10 exponent alpha equal to A. Okay. Is this clear or not? So now if you have, let's do it in Excel. Can you see my Excel? So in here, I created random value, the random value between 1 to 10, okay, as my x. So then, okay, so this is my data initially. So I will put as a special, okay, so that it will not now become a value, right? And then here, so I will put value random again, okay, between say 20 to 30. Okay, right? So there, and this data again, okay. Then I will put this into value. Okay. So there you have the data that we are creating. Is from the random values. Okay. Now, if we plot this, right? What will happen? So we plot this with the insert plot. Okay. So this is probably linear, probably not. Okay. So so what will happen is we can do linear regression using trend line, right? So in this case, for example, you have exponential and you put the equation on top on using power there. Then and you get this result of the trend line. Okay, now, how are we going to get this value, okay, using our computation rather than using trend line? Okay, so in that case, you create small x and small y, okay, which is based on the above derivation. So that means log of the x, right? And then this one also log of the y. Yeah. We copy this, okay? And then now what we do is get the slope and the intercept, right? So, but be careful, the slope and intercept is not from the original data. Yeah, the slope and intercept is from the transform data. Okay, so there. So the slope is y of the transform, and the X transform. With the intercept also is from the Y and the X of the transform data. Okay. So you can see there the slope is exactly the same, 0.0656. Yeah. But the intercept is not the same at 20 or something. Why? Okay, because this is still alpha. Then we need to get it back. Okay. Okay. If you want to get the A, okay, that means you want to get the 10 exponent to this alpha. Yeah, you get exactly 20.30. It is clear, huh? So it is, you can practice. Okay. I give you data here in the slide. Okay. I give you data of this practice. So 1, 2, 3, 4, 5, 6, 6 points. Yeah. Which clearly non-linear. And then try to create a power curve, logarithmic, and square root curve. Okay. And then harmonic and reciprocal and so on. So anyone have done this during the week? You can share. Yes, Will. You can share. You
Hello?
Yes, Win, you can
Yeah.
share.
Okay. Last week, sir, you assigned us each model to transform. I'm
Ah,
assigned 1 out of 8. So that's the power model, as
okay,
you also uh, shown us earlier. So here, the transformation would be A is equal to 10 to the alpha, and then B is just the beta.
okay. Can you share your work so that everyone can see?
Uh, Here, sir. Yeah. Is my Excel keep showing already?
Yes.
Okay. So here, I transform the data using log x and log y
Okay.
here. And then I get the slope and intercept using the formula.
Okay.
But also you can do as what said this has someone to ask earlier.
Okay.
And then computed the R squared. The linear transform model is around 0.99.
Mm-hmm.
Okay. Then alpha, the original A of the assumed model is 10 to the alpha, and B is just the slope data.
Okay. Yeah. So this is very nice, Win. Okay, you can claim your recitation. Okay. So you plot it in log. Okay, and then
Yes.
you can see that
And
this is
that
linear,
is linear.
right?
Yes.
So
Uh,
mm, excellent.
Actually, sir, I did all the models already
Wow.
in my spare time.
Super.
And have it plotted. The
Wow.
best would be the first one and the exponential.
Yes.
Uh, it uh,
You can
it
check the R
assumes
squared.
y, the
Yeah,
original y.
right.
Yes, sir. Uh, I've shown it on the table.
Okay.
The best R
But
squared is this one, model one.
correct. Wow. Excellent.
Thank you, sir.
Yes. Anyone else want to share if you have done similar? Okay.
Thank you.
Yeah, thank you. Thank you. June. Yeah. during the week?
Sir, I'm not sure if it's correct because I got a perfect R1 of 1
No? Share
and
your
the
work.
trend is downward. I was assigned, sir, I was assigned to do
Okay.
model number 7,
Okay.
which
So
is
that
y
will be,
equals to a plus b
so the
over
transformation will be of x equal to 1 over 1 plus x. That's correct. Okay, then you have the linear model, right? Oh, perfect. No.
I
The,
wonder if it is correct because I got a perfect R square of 1.
okay. So yeah, if the R square is 1, then it's correct. So it's okay. This is just imputed data, right? So can be correct. Okay, thank you.
Thank you, sir.
So you get the linear model, but you need to return it back to the original non-linear when you plot it. Okay, you still plot it in the linear one. Okay. Okay, Joe Ben, you want to share?
Sir, can I just reshare my work last time?
Sure.
Just share my Excel, sir. Starting again, sir.
Can anyone see Joe Ben's work?
Can you see my screen now, sir?
Yes. This is square
Yes,
root.
sir.
This is very easy.
Yes, sir.
Yeah, probably one of the
That's why I finished it last time, sir, when we ended our class.
Right.
So I'll just reshare it, sir.
Okay, good. So please
So
explain. Okay. So if you want, you can do all the others nonlinear transformation. Okay,
okay, sir.
good.
But here's the steps.
Right. Thank you.
So I just follow the steps here, sir.
Right. So is this table useful for you?
Yes, sir.
So if you know how to use this table, then next time when you have problems, so you just refer back to this slide. Yeah. Okay. Rather than you derive by yourself. It's already derived there. Okay, anyone else want to share? Anyone else? Going one? Okay, Mark Anthony. Go ahead, Mark. Oh, which model are you using? You are in mute. Okay, Mark, do you want to explain? Oh, So in here is the original data, right? And which model are you using? Can you go to this C so that we can see our model? T, column T. Can you go to column T? Mark. Okay, so the square root. This is the same as Schopenhauer. Right. Okay, 1 over square root. Yeah. Right. So eventually, if you use linear model, this is not correct. But when you use non-linear, okay, you may have a better result. Okay. Okay, thank you. Anyone else want to share?
Sir, I just did the same with Sir Joben.
Okay. You share it so that you can claim. Is that okay?
Can you see my screen?
Yes.
Not with, I did not do the transform data.
Okay.
I just did the regression.
Linear regression.
Yes, sir.
Okay, so please try the non-linear also so that you will know. Okay. Okay. So who else? I haven't shared yet. Breathness, do you want to share, Adrian? Yeah, anything to share? Point one, point two. Okay. Okay. So in that case, I'll share the next topic. Yeah? Go to the matrix part. Okay. I'll share the second. Right. Okay. So now let's come back to the simplest one. Okay. Say you have a linear model like this. Okay. Y equal to mx plus c. Yeah? So this is the bar on the top means they are the mean or the average. Okay. So then we can list the model for each data, something like this. Yeah? So say you have x1 to xn and you have y1 to yn. Okay. So in this case, the slope m and the c is the intercept. They are all the same, isn't it? For each row of the data. Okay. So you have n rows. Okay. So in that case, you can put this into matrix form. Yeah. So look at this. All the x, you put it here. And then C, okay, because C is alone, that means you multiply with 1. So in that case, you have 1, 1, 1, 1, 1. Okay. And then because matrix multiplication means each row multiplied by the column. So you will have this one, x1 times n plus c times 1. So then you have the factor here. Okay. And then on the right hand side, you put back into a factor also, y1 until yn. Okay. So in that case, okay, so in the matrix form, basically you have a matrix A with x and 1. Okay. And then you have a vector b, and then you have a vector y. So in that case, you can see you create a system equation. Okay. A times b equal y. So You probably learned this in high school. Okay, so that if you have A times B equal Y, right? So and if A is actually a square matrix, okay, so you can have A, okay, times B equal Y. Okay, in that case, you can just multiply with the inverse, yeah. So multiply the inverse with A, okay, and then I just copy this B, okay. That one equal to because the left hand side I multiply by A inverse, so the right hand side I'll also put the A inverse, yeah, exactly the same, and then multiply with the Y. So, but A multiplied by A inverse is actually identity matrix. Okay, so in this case, the same as B itself. Yeah? So then we will have the solution as if the A is actually a square matrix with the inverse, then you will have, okay, you will have B equal to A inverse, right? A inverse multiplied by Y. Okay, this is only happen, okay, if you have square matrix, okay, and you have A have inverse. Okay, so this is the inverse. Okay. But in reality, okay, A inverse not always exists, and then your data may not be the same as the number of variables, right? So, for example, in the regression above, okay, the number of data, okay, the number of rows is actually more than the number of variables. The number of variables probably only two, X and one here, right? But the number of data probably more than 5, okay? So in that case, we cannot use using square matrix, yeah, because there is no inverse. So then there's a trick to do this, yeah. We use what is called generalized inverse. Okay, so the trick is simple, yeah. First, you have first you multiply, okay, A with A transpose. Okay, so initially you have A times B equal Y, right? So then you multiply the left-hand side here with A transpose. In that case, the right-hand side also you multiply with A transpose. Okay, but A transpose times A is actually a square matrix. Yeah, any matrix multiplied by its transpose, it becomes square matrix. Okay, so because it's square matrix, we can multiply by its inverse. Yeah. But when we multiply by the inverse on the left-hand side, then the right-hand side will multiply with the same thing. Okay? But suppose this inverse exists, right? Then this part is actually identity matrix, right? So in that case, become B equal to this value. Okay? So this is look like complicated, but this is actually not that complex. Yeah, this form, okay, this form, okay, we can simplify into one matrix called L, left inverse. So the solution is, okay, B equal to this part. Okay. Now, if you put L equal to this part, then you can say that B is equal to L times Y. Okay, so by having generalized inverse, okay, then you can solve the regression. Okay, in fact, when you solve this, you can, because this is very general, okay, you can solve any regression, okay, as long as they are linear, okay, using the same equation. Okay, so I'll demo this in simple linear regression again. Okay, and then you can practice using multiple linear regression and polynomial. Okay, you can also do it using a classification and so on if you want. Okay. So let's take example here. Okay, say you have the earlier data. Okay, this is the data that you have, right? Then we put X here in Excel and the Y, okay, in Excel, we just type. And then what we will do is we form the X and 1. Yeah? So we form a matrix A, okay? And then we transpose it, okay? After we transpose this, okay, we multiply the A transpose with A to form this one, okay? And then we take the inverse, okay? After that, we create the generalized left inverse matrix, okay? And then you multiply with this Y, okay? Again, I just copy this here. And then you will get the slope and intercept. Okay, so let me demonstrate this in Excel. Okay, and then after that, you will practice this part. Okay, you'll practice this part. Okay, this one is multiple linear regression with two variables in the X and then one intercept. Okay, this is the output. Yeah, so let me do this first. Okay, so that you will know. So let me get the Excel open. Okay. Can you see my Excel? Okay, so let's type this here. So you can do it together with me. Okay, so this is the year, right? This is the population. So we have 1980, population is 2.1, 2.9, right? And then 3.2, 4.1, and 4.9. Okay, so in here we just add it to 5. Okay, so this is our data. We use the same data so that we can check the result. Okay, so this is the X, this is the Y. Right now we want to use matrix, so we form a matrix A, okay, which is the same as X and 1. Okay, so in that case, this is the X and this is the 1. So I will put here. So I will just copy the X, right? And then here is just 1. Is it clear? So this is the matrix A. So I will form it into this color. And then what we will do is we type in here A. Yeah. So, or maybe MA. MA, matrix A. There. So this one become matrix A. Can you see? Yeah. So, and then what I will do is to create a Y here is a vector Y. Okay, so I will just copy again here. And I put it like this, and I put the vector y. So I give name. This one is vector y. Can you see? Now I need to create a transpose. So I need to create a transpose. So a transpose. Okay. So this one is a transpose. Right. So A transpose. How many rows here? 1, 2, 3, 4, 5. Okay. So in that case, you need to put transpose of A. Can you see? Okay, you just type like that. Still values, no problem. Most important, you need to know the size. Okay. What is the size of A? The size of A is 5,1, right? So in that case, what is the size of A transpose? Should be 1,5. Oh, sorry, 2. 2,5, because this is actually 5,2. Yeah, sorry. 2 column, right? Okay, so 2.25. So in that case, you highlight, okay, 2 rows and 5 columns. 1, 2, 3, 4, 5, like this. And then you click here to edit. And then don't forget to press Shift, Control, and Enter together. Yeah. Yeah. So the point, you need to use Shift, yeah, plus Control plus Enter. Okay. This is to do matrix or array operation. So can you do that? Next, okay, we will multiply, yeah, A transpose with A, right? Multiply with A. So this transpose is actually superscript. Okay. So A transpose is 2 and 5. 2,5 multiply with 5,2. So in that case, the result should be 2,2. Okay. So there. So what you will do, you multiply M mode. There. Yeah. M mode of what? A transpose. Okay. Before that, let's give a name. So this one is AT or MAT. MAT. Okay. So then we will multiply M mode of MAT, you see, with MA. There. So it's very nice to see invariable. Okay. And then you press here, highlight, because this is 2 by 2. Press in the edit, and then don't forget Shift, Control, Enter again. Yeah? There. You get the result here. Okay. Once you have this, okay, you want to get generalized left inverse L. Oh, before this, we need to inverse this one, right? We need to inverse of this part, yeah. So we need to inverse this one. Okay, so this is great. So this one is just inverse and inverse. Yeah, and inverse of this 2 by 2. Okay, and again you highlight 2 by 2, edit here, and then press Shift. Okay. So you will get the result here. So let's give name. This one is inverse, yeah, ENV ATA. Okay. So once you have that, then you can create the left generalized inverse. You remember the formula a while ago? Formula of left generalized inverse is inverse of this multiplied by A transpose, yeah? The same like this one. And then multiply with A transpose. Okay, so all transpose will be on the subscript. Superscript, yeah, this is also superscript. Okay, there. So we already have this one. So we just need to multiply this part with this part. Okay. But we need to know the size. Okay. So the size of this is 2 by 2. Okay. And this one is 2 by 5. Okay. So we multiply this 2 by 2. Okay. Multiply by 2 by 5. Right. So equal to 2 by 5. Yeah. Okay. So in that case, M mode of this inverse multiplied by this one. Okay. Now, if you just type that, you will get only one value, but you need to get 2 by 5. So 1, 2, 3, 4, 5. You highlight first, and then you edit here, and then Shift Control Enter. Now, you get the result of L, right? So then, if you want to get the vector B, okay, it's just L times Y. Okay, so B is equal to L times Y. Okay, so what is the size? L is 2 by 5. Okay, Y is 5 by 1. So in that case, the result is 2 by 1. Okay, so then M mode again, M mode of this L. So let me give a name first. ML. Okay, so there. So we have M mode of this ML multiplied by this vector Y. Okay, and you highlight this two, and then Shift Control Enter. Oh, that is exactly the same as the regression last time. So this is the result. Yeah. So I hope this is clear. If you have any question, go ahead. You can ask. Or you want some time to practice this.
Can I share my screen, sir?
Okay. So, okay.
Sir, can you share the Excel file also?
Hmm?
The Excel file.
The Excel file, what?
Can you share
Oh,
the
you want me
Excel
to
file
share?
also?
Okay, let
Yes,
me
sir. Thank
share
you.
the Excel file. Let me save first. I will save temporary file. Save as. Okay, regression. And, shall I share it in the Zoom? Hmm?
Yes, sir.
Okay, so I will share to all. Oh, wait, I need to. Okay, again. Okay, I'll share it all. Japan, you can share your screen.
Can you see it now, sir?
Yes.
So I just followed your instructions. Use
Okay.
the matrices, the A matrix, the Y,
Okay.
then the transpose. But I did what I know about matrices. So I did this.
Yes, that's correct.
The matrix multiplication M
Yeah.
mul like
The inverse is
I'm
M inverse.
yes sir, M inverse because I'm confused with the renaming, so I did what I
Okay.
used to.
Renaming is just to keep a name of variable so that you can see clearly.
Yes sir.
Okay, that's optional, right?
Okay sir. So I just did what I'm
Okay.
used so
And
I
you
can
get the
understand.
result, right?
Yes sir. Then here is the L, the
Okay.
2 by 5.
Okay.
Then the B. I think sir the B is this is already the slope and the
Correct. The
intercept.
slope and the intercept. So
So
you
I
can
got the value of the Y at 2005,
okay.
5.48.
Super. You also predicted. Yeah. Super. Okay. Thank you. Don't forget to claim your recitation. Okay, Joven, and the others also. So, is it clear or not? Or you have any question? So then, if this is clear, okay, you need to do the practice, okay, of multiple linear regression. Okay, so a little bit harder than a simple linear regression. You need to add addition. Yes, Vin, you already.
Sir, I already did this on the weekend.
Yes, I saw a while ago. So go, we share it again
Okay.
so that the others can also see.
Okay. Is it showing now, sir?
Wow, this is the supposed to be the assignment. Yes, super. Right.
Okay. For multiple regression, sir, you just add one for the new variable, which is the distance in kilometers. So the A matrix, instead of being 2 by n, would become 3 by n.
Very good.
Just for the constant, the ones, uh, this corresponds for age, and then this corresponds for the what was taught in class, the generalized inverse. You get a 3 by 10 matrix because of there are 10 data. And
Right.
then we get three values on the B vector. This one, the 900,000 for the constant,
Okay.
negative 24 for the coefficient of age, and negative 19 for the coefficient of distance. Now, if we want to forecast the price at any given value of age and distance in months and kilometers respectively, you can get them.
Right.
based on this model.
Super. Win.
Thank you, sir.
Yes. Excellent. Excellent. Okay. So look at this value. Okay. The 900,000. Okay. This represent what?
The constant, sir.
Yes. So now you need to interpret this. Okay. So what will happen if the age is 0 and the distance is actually 0?
Base value of the price.
So you will get only the, yes, that is the new car, isn't it?
Mhm.
So this is 900,000 pesos is actually the price of new car. Okay. And look at this 24 point something there. Okay. What is this? This should be negative, isn't it?
Yes, sir.
Why negative?
Because as you
Depreciation, sir.
age,
Yeah.
the
Yeah.
price
As
depreciates.
you age, okay, this is the price of new car. So 900,000 initially. But when you use it, of course, okay, every
Depreciation.
month you use, it will reduce 24 pesos. No? Okay, right. So this is basically the margin, the slope. Okay, yes, because of the age. Correct. And then the last one is a 19 point. What is this?
This is also negative because for the
Correct.
coefficient of distance,
Okay.
as you go higher
Right.
fuel prices, as you go
Excellent.
longer.
This must be negative also, okay, because as you use it, the longer it is, okay, then this must be also reduced. Yeah? The price reduced by the kilometer, okay. So actually, because per kilometer is actually very high, it's 19, almost 20 pesos, no? More than because this is in month and the other one is in distance.
In kilometers.
In kilometers. So of course, in one trip you will have many kilometers. Okay, so
So
that
for polynomials of
same.
the same variable x, you just add the many terms of the polynomial on the
So
vectors.
in the polynomial, for example, you have x and then x squared, x to the third. So in that case, the column, yeah, should be 1 and then x, then
X
x
squared.
squared, and then x to the third, and so on.
So you've given us the hint for the homework already, sir.
Yeah, with this you
The
can
L and
do the
X
homework.
and E to
That's
the
correct.
S.
Yeah. So you need to do the transformation of that to this linear, which is actually simple. Yeah? As long as you can put it into matrix, okay, everything is rather simple. Okay.
Okay, thank you, sir.
Super. Super. Yeah. Okay. So let me come back to the slide. I need to share it. Joben, you want to ask something?
Sir. Hello, sir.
Yes.
So for the homework on forecasting, we will predict the population and registration data.
Suppose you have population and registration data for your city or for your province. Okay. If you don't have it, it's national data, that's fine.
So we will do two tables, sir. X year, then population, then X year vehicle
With
registration.
the yes.
So two tables, sir.
Two seats. Okay, one seat is for population, the other seat is for the vehicles.
Okay, sir.
Okay.
Thank you,
So
sir.
right. And then I suggest to use this non-linear model and then try to use into linear and then put it into generalized inverse, yeah, using L a while ago. Okay.
For the data, sir, how many years is your, for example, the requirements, sir, the data?
Or if you want to use to derive for 5 years, probably you need also more than
5
that.
years. Okay, sir.
Right. So if you want to predict for 5, so you need at least the same number of your prediction,
Okay, sir. Thank you, sir.
right? Okay. So let's do this nonlinear. Okay. So this is the one that Vin showed a while ago. Okay, for your practice. Okay, you already did that. Okay. So now depending on the type of the model that you have, okay, in here I put the intercept A is in the first one. Okay, and then B and then C, right? So in that case, I will put 1 in the first column, okay, and then B times 8. So this 8 in the second column. Yeah, I just copy this, okay, and then the third one, sorry, is the kilometer. Again, we copy into matrix A. Yeah, right. So and then the dependent variables, okay, here is just copy from the output, yeah, which is the price. Okay, and then what we need to do is to create that, yeah. So here exactly the same like what Vin was doing, yeah. So we create a matrix A, and this is the data, okay. And then what you will do, you transpose it, we multiply the transpose with A, you get the inverse, and then finally you get the exactly generalized inverse, and then from there you multiply to get the coefficient. Okay, once you get this coefficient, then you start to interpret. Yeah, so what's the meaning, okay, of this 900,000 is basically the price of the new car. Okay, so what's the meaning of minus 20 and 24? Okay, is the margin, yeah, or the slope for the age and the kilometer. Okay, so once you have this model, okay, it's calibrated, right? Now calibrated means you already have the parameter, yeah? This is the parameter value. So once you have the parameter value, the model is calibrated. Okay, so then you can predict. Yeah? So this is the prediction. How to predict? You input the age and the kilometer, you will get this estimate. Okay, and then the estimate minus with the price, okay, you will get the error. Okay, of course the error can be positive and negative, and then if you sum the error, it will become 0. Okay, now then you can start to predict which is outside the data. Yeah, so estimate here is to get the error, meaning based on the data. Yeah, in here is prediction which is outside the data. So say if you have certain age and certain kilometer, how much is the price? So then you just put that value, okay, into age and kilometer, so you will get the estimate of the price. Okay. Now, okay, so if you have this regression model of the price, okay, then what is the meaning of A, B, and C? Okay, and then what should be the range of the value and the sign, okay, for each parameter? So after you do the regression, okay, you need to do what is called dimensional analysis. Yeah, you need to check the unit. Okay, so check the unit. Yeah, so look at the model. Okay, so this is the model, right? Get different color because this one has a lot of red. Okay, so price, the model is in pesos or in US dollar. Okay, the same. We have age is in month, right? And the mileage is in kilometer distance. So we don't know these three A, B, and C, right? So then what you will do? We input one by one, yeah? So for example, if the age and the mileage are 0, both of them, okay? So in there, if this one is 0 and this part is 0, then the price is equal to A, isn't it? So if in that case, the price is equal to A, that means this is new car. A is practically new car. Okay, that means the unit of A is also the same as the price. Okay, so now I have the unit of A is equal to the price. Okay, how about this part? Okay, again, if you want to know this part, okay, next is the mileage. I put as 0. Okay. If you put mileage as 0, okay, I don't know that. So you have the price as US dollar, A is US dollar. How about this one? P times 8. Of course, P times 8 must be in the same unit, right? You cannot add of different unit. So additional must be in the same unit. So in this case, P times 8 must be US dollar. In that case, because 8 is already in month, then P must be US dollar per month. Okay, so from here, you know that this is the gradient or the slope. Okay, we call it margin of the price by the age. The same things now, if you use the first one now set it as 0, then you have A and C times the mileage, isn't it? So in that case, this part, C times the mileage must be in US dollar also. Then mileage is already in kilometer, then C must be in dollar per kilometer. Okay, so in that case, we know that C, okay, is the gradient or the margin of price by the distance of the mileage. Okay, by doing dimension or the units analysis of the dimension, then you know the meaning. Okay, and after that, you need to check the sign. Okay, because A is the initial price. Okay, then it must be positive. Okay, and then B in here is the margin of the price over age, and this is the margin or the slope of price over distance. The two of them must be negative. Yeah, so this is based on the logic that you know. Okay, and if you want to know the range, whether your value is correct or not, you need to know the range, right? Then you assume something. Okay, so for example, you assume to the extreme. Yeah, for example, because this is a used car, have no more value after say 15 years. Okay, and after 5 million kilometers. So, well, you can put any numbers as long as they are still reasonable. So then you can say 15 years you multiply by 12, that means 180 months. So in that case, you put it into the formula. Okay, then you have the value of P and C. Yeah, okay. This of course depends on A. So in that case, you know, okay, the value of P is between this negative value until 0. Okay, and the value of P C is between this negative value up to 0. Okay. If you want to know the value of A, you just go to the dealer. Okay. Just conduct simple survey. Okay, with that, you can calibrate and verify the model. Okay. Now, in real life, okay, things are not as simple as this. Okay, after you do regression, okay, you need to distinguish. Okay, say you have many variables to using survey. Okay, and then you need to distinguish between the type of variables. Variables which is called policy variables. Okay, this is the decision variable, something that you will use in your model to decide. For example, in trip generation, probably population, economics, and land use, they are policy variables. In mode choice later, the vehicle cost, vehicle kilometer, these are the policy variables. Other variables, for example, the age, gender, socioeconomic factors, they are other variables, which you can include or not include. Now, if your model have correct sign, check the t-test of each variable. If the t-test is significant and they are a policy variable, then of course you need to include, right? And if they are significant and they are other variable, you include also. If the sign is correct but they are not significant, and you can include their significant policy variable even if not significant, but you may reject if they are not policy variable. This significant or not depends on the t-test, for each variable. Is that clear? Now, but if the variable have wrong sign, then you are starting to have problems, especially if they have significant value of the t-test. So if they are policy variable, you have big problem. If they are not policy variable, you simply reject. So what's the meaning of big problem? That means probably you need to change the model. Probably not linear, probably non-linear. So you need to change the model in order to make it significant. So again, this is art and science. There are science that you can do, but not necessarily you can get what you want. Last time, what I'm doing, sometimes I can do just 2 months just to model like this because we cannot get the significant variables, especially in the policy values. So this is very difficult. Modeling is not easy as you think, especially when you have significant policy variables. Next, if you have multiple linear regression like the price of the car a while ago, so this is what you need to do. First, you have x1 to xn. Suppose this is the variables, independent variables, and y is your output, right? Then what you will do? You need to list all the combination of the model. And here is the criteria to select the best model. You are not just selecting the highest R squared. This 2 step is very important. What? Number 1, check the correlation. Check the correlation. In Excel, you can do the correlation. Right? So check the correlation, and here it is. There is no high correlation between X. Between the independent variable, you must not have high correlation. Why? Because if they are in the high correlation, that means they are actually repeating the same things. So second, you test the t value, the significant f, and then the R square, right? So this must be passing all these 3 tests. Then you can get the highest R square. So I will give you examples so that you will know what the meaning of possible combination and correlation. This one I think we already did last time. Let's say I have 4 variables, x1, x2, x3, x4, and here is the correlation matrix. You can just do this using data analysis, correlation, you can get this. Look at this correlation matrix. Okay. This is the y. Okay. Of course, in the diagonal must be 1 between itself, right? So, and then because correlation matrix is symmetric, so I don't need to put the upper part because they are exactly the same as the lower triangular. Okay. So look at this. Which one have high correlation? This one. Okay. Okay. Between x1 and x3, they have a very high correlation. That means x1 should not be together with x3. The same thing here. X2 and x4 also have a high correlation. That means x2 and x4 should not be together. Okay. So, and then between x and y must be high. So, but they are all small, right? So that means the first one, okay, this one, no more, because they are all small. Between x and y must be high. Then you can use this model combination. And this is our list of all combination model. Okay. So 1 variable, 2 variable, right? And then 3 variable and 4 variables. These are the combination. So this is why this is not okay, because the value is small. Can you see 0 point less than 0.8? Okay. So less than 0.6, I remove this one. And then this one, x1 and x3, very high correlation. Between x should not be together. Yeah, should not be high correlation. So because they are high correlation, so I remove this one. Yeah, this is also I remove. This one I remove. Okay. Between x2 and x4, because this is also high correlation, so I need to remove also. Everything with x1 and x3 I remove. This one x2 and x4, so I remove. This one x1 and x3 I remove. This one is x2 and x4, so I remove. This one, all of that also I remove. So finally, what we have is only these 3 model, yeah? 1, 2, and 3. Okay, so these are the 3 model that you need to test with t-test, f-test, and r-square. Okay, first you need to create the combination, and then you remove, okay, based on the correlation. Is this clear or not? Any question about this? So, do you want to practice the price a while ago? Price of the car? This one? Yeah. I know Vin already did it, but the rest of you did not, right? So, can you practice this? I think you can do this in just 5 minutes probably. Okay. Once you finish, can you share your screen? Huh? Yes, Vin.
Sir, when testing the multicollinearity, it's just the correlation coefficient, not R squared, or with that we are testing.
Do you know why?
Yes.
The most important is why. Of course, there are more than that correlation. Okay. So when you have, okay, can you see my screen? Okay. This one, right? So when you have high correlation, okay, like this, okay, say this one, yeah, X1 and X3, okay, have high correlation. Basically, they are, if you have a high correlation between two X, basically X1 is actually the same as X3. You can replace this. Yeah. In here, you have X2 and X1 is very high. So in that case, you can replace X2 is actually the same as X4. Okay. So now if you include the two of them in your model, okay, as separate variable, okay, then your R square will become very high, redundant. Okay. When you look like getting a very good model, okay, but because of redundant, they are actually the same variables. Okay, then your model is practically wrong.
Not accurate. But sir, on the test statistic that we use here, it's just R, not R squared. For correlating, for example, X.
This is the simplest statistic that you use. Okay, number one is P, F, and R squared.
Okay, all R squared. Okay, sir. So
Yeah.
this is assuming linear models for each variable, sir.
Yes, this is assuming linear model.
Okay.
Okay, so the F and R square is for the whole model. Okay, while the T, the absolute T value is for each variable. Okay. So if in reality, if you want to go more detail of this, okay, you need to test a lot, like rather than just these three. Okay, for example, you need to test whether the normal distribution is not violated. Okay, and then you need to test also whether the variance is constant. Okay, not and then of course correlation. So these are the usual common tests that we use. So if the variance between the model is actually enlarged, okay, then you need to do another transformation. Okay. And if the result is not normal distribution, for example, based on the outlier, okay, then again you need to use different model, not linear model. Sometimes if you see that there is some pattern which is clearly quadratic or non-linear, okay, in the outlier, then you will see that. Then you will say, okay, this is not correct. Then I will use different model. Okay. Assuming your model is correctly linear, then all the things that you need to do is just these three. Okay, so go ahead, you practice first.
Sir, can I share my screen for the test? Okay.
Cool.
For example, sir, using the same example, price as a function of age and kilometers. So we do first the test for collinearity between the independent variables. And when the R squared is low, you may say that they are not strongly correlated,
Yeah, they should not be correlated.
age and distance.
Right.
And then that's the T statistic. According to the slide, if it's greater than 1.6, it's good. The absolute
One
value
must be larger than 1.9, which is
1.6.
all correct. Larger than,
Okay.
in absolute value.
All p values are less than 0.05.
This is the same. Yeah. P value is actually less than 0.05 is the same as the T stats.
Okay.
Okay.
And then for F, it's
Less than
the same, less than
0.05.
0.05.
Yes. Super. So now you see the normal distribution plot
Here, sir.
and the
This one.
residual plot. You can see, oh, this one is okay. The residual plot is, there is no real pattern, right? So they are okay.
Mm.
Yeah. So
So
the,
you also look at, since we're assuming linear regression, we look on the distribution of x variable against residual.
yeah, so for each variable you need to plot. This is
If
correct.
there is a pattern, maybe that's not linear. Is that correct, sir?
If there is a pattern, then this is not non-linear,
Okay.
right? If linear model, the pattern must be like within the horizontal band, like this. This is practically no pattern.
Okay. This one should be random
Random.
for x versus y. Okay,
Correct.
thank you, sir.
Very good.
I think I understand better.
Yes. So you can check the what will happen if, for example, if from the plot of the outlier, you will see the spread is getting larger, for example, the residual. If the residual is getting larger, then you will, or getting smaller, from peak and then getting smaller. Then you will see, oh, this is variant is not constant. So residual plot is very important to see that. Okay. There are certain terms that we can use. Okay. Anyone want to share your work on this? Or you need some time? I will wait. So you can type in Google this term. Okay. Heteroscedasticity. Yes, Jogan, you want to say something?
I'll share my screen, sir, for the price.
Ah, can you share? I will close. Yeah, I did not share. Go.
Here's the
Oh, super.
same as Servin, sir.
Mm.
The A matrix, the independent matrix. I just put the dependent matrix at the end because I'll just use it
Yeah,
at
yeah,
the end.
yeah.
So
And then
I
you
first
get the correct
transpose.
result, the same ABC.
Yes, sir. Here's the B matrix.
Very good. Okay,
Yes, sir.
excellent, Joven. So anyone else want to share? Okay. Vin, Joven, check the term heteroscedasticity. How do you spell this? Heteroscedasticity. And check. Okay, and the variant is not constant. Okay. Okay, then. The assumption of linear regression is okay, their normal distribution with a constant variance. Okay, so if one of these assumptions is violated in any model, so there are many assumptions that you need to know. If the assumption is one of the assumption is violated, then you cannot use that model. So, correct. Okay. In any modeling, okay, they always based on certain assumption. So you need to know the assumption. Okay. The difference between people who has knowledge and people who doesn't have knowledge is this. Okay. Those who have knowledge, they know the assumption behind. Okay. Then they can check whether this is correct or not, whether the assumption is violated. If not, then they need to change into different model. Okay. Those who have no knowledge, okay, they just use the model and then insist that this is the correct model, even though the assumption is violated. So that's why don't just use the model. Okay. You need to know what is this model about? What is the assumption behind? Okay. Okay, then. Do you need some times or you want to skip? Because some of you already presented. Okay, so let's continue. Okay. I'll put this in the flip chart. So you have forecasting as your assignment. Okay. And let's go to this next topic, trip generation. I will share this. Okay. Can you see my slide? Yeah. So we are in the first step of the four-step model. Four-step model is trip generation, trip distribution, model split, and traffic assignment. Okay. So in trip generation, okay, the whole map or the whole region or the whole city that you are interested, okay, you put them into zone. Okay. So now in the zone, okay, say suppose this ellipse is your study area. Okay. And then you want to know, okay, this study area is the block part here. Okay. Then you want to know how many trips inside. Okay, what is the inbound trips and outbound trips, and then through trips. So from external to external is called through trips. Okay. Inside your study area is called intra trips. Okay. And of course, from external to internal become inbound. From internal to external become outbound. Yeah. So why this is important? Okay. For example, in a city, city center usually, okay, if they are actually just want to pass from one city to another city, your study area is one city. So the through trips, then these through trips, if they are very big, you can put these through trips in the ring road, for example, okay, through a tollway, rather than going inside the city, isn't it? Okay, so because they are not important in the quote for the city itself, they are just passing. So in that case, we want to know how much is the true trips. Can we deviate these true trips? Not going inside the city, but outside directly. So that they can pass only. So that is how you compute the visibility, for example, for the tollway. So many trips is actually through trips, then you don't let them go inside, contributing to the traffic inside the city center. Okay. Then, of course, inbound trip is important to check what is the time, and the same thing with outbound trips. Okay. So in intra trips, which is inside the study area, inside the one city, is practically from the population of that city inside. So now in the zoning, don't forget to include the external zone outside of the study area as one zone outside. And then you can also create a hierarchical of zone. So this is an example. So you can create the zone, and then you can create subzone. Okay, and then you can put them into some district, and then you can put them into some sector if you want. So usually the zone based on the data that you have. For example, each district, or in the Philippines you have barangay. So each barangay have certain census data based on economic and land use and population. This is the most important three variables. Okay, so and then of course within the study area, maturity should be intra trips. If they are through trips or from inbound or outbound, so something is wrong within your study area. Okay. Now, these are the typical zone numbers in various studies. Okay. So you see the number of zones between small number to 50 up to 2,000. So it's quite big city. So they have a different type of number of zones depending on the population. Okay. So of course, the more disaggregate, meaning the more zones, and the better it is. Okay. But each zones will have their own data, so population data, economic data, land use data. Okay. Now, trip generation is the analytical process that provide the relationship between urban activities, land use, economic activity, and travel. Okay, so this is the meaning of trip generation. So In this case, there are several input. The land use is the input, the activity is the input, socioeconomic as the input. Okay, and then the output is just what is called trip M. Yeah, so we have trip production and trip attraction. Yeah, so we will use this symbol OI and DJ. Yeah? O mean origin, D mean destination. Okay, so the goal of trip generation model, okay, Y is a function, okay, of X, right? So the X here, these are the input, okay, the output, the Y, yeah, 2, not 1, but 2, yeah. OI, which is trip production, the other one is trip attraction, yeah. So from one zone, how much it produce, the trips. Here, we are talking about person trip, yeah. Not vehicle trip, yeah, person trip. Okay. So, okay. So, this symbol represent from outer zone, how much they will go into attracted to this zone J. Yeah. So trip attraction, okay, is from other zone to this zone. Yeah. Trip production from this zone to other zones. Okay. So then we are talking about land use. How do you say the land use? Of course, depends on the land use type. Okay, so example, residential, commercial, hospital, recreation, and so on. Then for this type, you start to measure the activity. Okay, so you can create any variables to measure the activities in that land use to represent the land use intensity. Okay, so the variable that you set is free, it's up to you. Okay, so example, ada example. Okay, so in the residential area, you're talking about the number of person living in that zone. So this is population. Or you don't just get the population, you also include the number of workers. Okay, or not just the number of worker or population, but you divide by the area. So in that case, number of dwelling. So number of residential units for example, per hectare. Okay. Or instead of the number of people, you are also including the area, for example. So these are the input, right? The X. So what is the output, the Y? We call it OI, which is production, yeah, reproduction. Okay. Now, if your land use type is industrial, okay, then you are talking about the number of jobs or the square kilometer of the area. Yeah, so this is the input. The output is the number of trips. Okay, and person trips. Okay, the same thing. Commercial area. Okay, you are talking about, for example, the floor area, the number of parking stall in the zone, and so on. So again, because this is not residential, okay, everything that residential will produce, again, we will have trip production, yeah, OI. Everything that is non-residential is always DJ, meaning trip attraction. They are attracted to that. So, yeah. So, how about school? What will be your measurement? Number of students, okay, number of classes, number of teachers, right? Or the area of the school itself. Okay. So hotel, the same thing, and number of hotel. And so if there is a movie theater, then the seating capacity that represent the input, the activities. Okay. And the output is the trip ends, okay, how many people are attracted from there? Okay. So up to here, is there any question? So you need to know, right, the variables, yeah, the input. So there are several standard, okay, what is called trip generation handbook, for example. They already did the survey, okay, for certain type and certain measurement, okay, usually have how much they will generate, the trips and person trips. So then from that handbook, you will get the value that you can use. Okay. Next, how they check the number of trips. Yeah. So the number of trips that they check depends on, okay, depends on the vehicles later on. Yeah. So say you have in an urban area, okay, the mode is like this. Okay? So for example, walking, bicycle, motorcycle, okay, and so on. Okay. So then if one trip, okay, consists of several modes, okay, then only the highest mode is reported. Say for example, oh, where are you going? Oh, I'm going from my home to my office. Okay, how do you do to go to your office? Oh, first I walk, okay, and then I use taxi, okay, to go to, for example, to the train station, and then I use train, okay, and then I walk again, okay, to the office. So in that case, the one that reported is the actual train, not the taxi. Okay. Of course, you can also report everything, but sometimes if you put so many, you cannot get what you need to do. Okay, so in this example, okay, the one that reported is actually the highest mode. Now, based on this, okay, based on the highest hierarchy mode, okay, if you want to do the number of survey of the number of trips, yeah, then usually we don't include the baby. Okay, children under 5 years old, we don't include. And then you will ask, okay, how many trips from one origin to destination is called one trip. Remember, this is person trip. Okay. The input area is the land use activities a while ago, but you need to get the output, isn't it? The output is person trip. So person trip, you need to do survey to us. Okay, so there are many types of survey. Okay, one is questionnaire survey. Okay, so also you check the trip purpose. Okay, for example, in one day you will have multiple trips. Okay, so we call this trip chain, and a trip chain have different purpose. Okay, then for each trip purpose, you will know the origin and destination and what time. Okay, then you count. Okay, as trip production or as trip attraction. Is this clear or not? So the X is clear, which is the input. Yeah, it depends on the land use, okay, the population, okay, and the area. Yeah. The Y is the person trips, okay, from origin to destination. So this one must be surveyed. So this kind of survey is called OD survey. Yeah. So this is the basic data for classical transportation model. If you don't have this data, basically you cannot produce good model. Is it clear or not? So you need to know the person trips, okay? And then you check reproduction and trip attraction. Okay. Next, based on the trip purpose, what are the possible trip purpose? Yeah. So work or school, maybe shopping and social activities, recreation, health, just to accompany others, or other unclassified trip purpose. Yeah. Or probably they are just commercial vehicles. So this is trips. Okay. Some will say they return home. So in this case, we call this trip production also. Yeah. So trip production and attraction is depends on the home. Yeah. Return home is also called trip production. So now among these three purpose, we have very important category. One is called compulsory or mandatory. The other one is discretionary or optional trips. Okay. Compulsory, they need to go regardless, right? They need to go on the certain time. So okay, this is commuter. Commuting, the word commuting or commuter, this is based on compulsory trips. While discretionary trips, okay, they are not necessarily at that time. They can delay the trips. Okay. Next. In trips, okay, we have OI and DJ. So this is the trip production and trip attraction. So check what is the base. Yeah. So we have what is called home-based trips. Okay, which is the trip that start from the home or end to the home. Okay. And then we have also what is called non-home-based trip. Okay, which is the trip that start from or end to the non-residential. So residential is separated from the non-residential. Is this clear or not? Okay, so when you are going home, okay, that is we call it home base. Okay, when you go from home to office, that is called also home base. Now, if you go from the office to the supermarket, that is non-home base. Okay, so here is the example of how we count. So the trip production and the trip attraction is not depends on the direction of the movement, okay, but depends on the land use type, home base or not. Okay, so when we say trip production, okay, that is anything that the origin of non-home based trip. What's that mean? Okay, so the origin of non-home based trip, okay, but they go from the non-home base, okay, and then you go from home, okay, to certain area, and then the home based trips, the home end of the home based trip is called trip production. Well, in trip attraction, it is actually the destination of non-home based trip or non-home based end of home based trip. Okay, this is an example here. Okay, so you have say you go from residential to certain non-residential. So this is the origin, this is the destination, and then you go home. All right. So how many trip production? You have 2 trip production. How many trip attraction? You have 2 trip attraction. Okay. Now here is another example. Okay. Your trip is from home, which is your condo, and then you go to office, and then you go to supermarket, and then go home. Okay, so these are your trips. Then, because this is from the condo, so this is home base, right? And then going home, this is also home base. Yeah, home base purpose is working. This one home base purpose is shopping. Even though, look at the direction, going home. Okay. Now, here from office to supermarket, this is called non-home base because there is no residential here. Okay. Now, if you want to count the trip production and attraction, okay, so here, okay, you have trip production. Okay, here you have one trip production and one attraction. Yeah, why? Because this is home base, right? So this is one production, and this is one attraction because this is non-home base. The same thing here. We have one attraction and one production. Yeah, because one is non-home based, the other one is home based. Is it clear or not? Yeah, these are the guide. Okay, to determine pre-production and pre-attraction. So next, this is the survey that you need to do to get the person trips. So you will ask them, okay, their daily activities, okay, and then say they come from home, okay, and then going to small, what time, and so on, okay, and then you plot this into one graph like this. This is the graph for one person. Okay, this is one person trip. So you will check, okay, what time, okay, and then where, what is the purpose, okay, and what they are doing. Okay, it can be a freight trip or passenger trip. Yeah. Is this clear or not? So there's an impact, yeah, on this traditional method of what is called home-based assumption. Yeah, and this is the actual problems of the traditional method. Yeah, can you see? Yeah, in the diagram here. Yeah, so in this example, you will see that one is empty, yeah, the other one is full, because the way we make the model traditionally is home-based or not home-based. It's one way. So this is clearly inefficient in terms of the space, isn't it? Yeah. And we can also see this is also inefficient in terms of the time. You see, this is the typical urban travel by purpose and the time of the day. Yeah? So this is 24 hours, so 0 is the same as 24. See this, we just copy. Okay. And depending on the green here is trip to work. Yeah. Yellow is social, recreation, and shopping is red. Okay. Some people still shop in the night. Okay, but majority of the shop trips is actually during this time, yeah, between 9 to 16. Okay. And majority of the work is between this about 7 to 9. Is that correct? Yeah. So you see the green part here. And going home, the majority of the work going home, people who between 4 o'clock to 7 o'clock, yeah, the green part. Okay. And when you take the average, okay, so you will have this value. Okay. So there's a peak hour. Okay. So morning peak, afternoon peak, and then evening peak. Okay, so now if you one way to solve this is actually to make it more efficient is to stagger. Yeah, in terms of management, so we allow people to go to office or to school, okay, at different time, so that they will have uh, spread in terms of the time to go, so that they will not have peak hour. Yeah. So social life is mostly in the night. Can you see? Yeah. Social life is mostly in the night or in the afternoon. Yeah. This one, the yellow part. Now, you can also create, based on your survey, okay, you can also do what is called time and space diagram. This is an idea, okay? So with all this travel daily pattern. So this is the time, okay, down here is the time, and then this is the distance, yeah, from your home to other place. Yeah, so space in here is the distance between your home to other space, and these are the three purpose. Okay, so say you start from home in the morning, and then this is your workplace at work. Okay, and then you do some shopping, travel to the store, and then you go home. Okay, and then you travel to go for dinner, and then you go home again. Right. So the red part here is the actual distance. Okay, and these are the daily pattern typically for one person. Okay, once you do the survey, then you can create this kind of drawing. Okay? So time and space drawing. And question is, what is this for? Okay, so one example of travel daily pattern application. Okay, if you want to check the pattern, okay, what will happen if we do congestion pricing? I heard certain city, yeah, maybe Baguio want to create a congestion pricing. Is that true? Okay. So say before the base case, this is the base case. Okay, so you will see the typical time and space diagram. Okay, this is the home, right? And this is the work. And say they go to shop here and then go home. Okay, and this gray area here is the peak hour. Yeah, this is the peak hour. Okay, and say they use car. Yeah, so this is the base case, the base scenario. Now, what will happen if you start to do congestion pricing? Okay, during peak hour, they need to pay certain toll. Okay, so then these are the potential responses. One is they will start to work from home. Okay, what will happen if they work from home? Okay, so this is the home pattern, can you see? Okay, and then they will just go to shop, but they will avoid the congestion. Okay, so they will still use car to shop in the afternoon, yeah, not in the peak hour. Second pattern is to change the time and the yeah, the same. Okay, they will shop. Okay, before they will shop in the going home. Now they change. Yeah, here they shop in the night. Yeah, they will go home first and then they shop in the night. So they will also avoid the congestion pricing. So then they will go home before the congestion happen. They will go to the office earlier. So this kind of change of pattern will only happen if the management allow them to have a staggered work hour. meaning they will go earlier or they go later. Yeah, so they will try to avoid the congestion pricing. Okay, so that during peak hour they will not pay the toll. Okay, the next is, okay, this is what we hope is to change the mode. Yeah? Instead of using car, they use public transport. Okay, but very important if you want to apply congestion pricing, okay, do not ask the public transport to pay congestion pricing also, right? So if you do that, then your purpose is not efficient, not effective. No? So I saw a lot of illogical policy within my stay in the Philippines. They charge the public transport more costs. Then, of course, the cost will go to the passenger. In that case, you don't solve the congestion problem. In fact, you need to subsidize. So the government charges the more to the public transport. It is a strange policy, I think. Yeah, it happened. So now, if you want to include a model of trip chain, okay, so here are the example of the input. So you will go to the social economic. So in this case, you include the income. How much is their income? Do they own a car? How much? How many family members? Okay, family size. Okay. And then are they single? Do they have family? Okay. How many people work in the family? How many children? Yeah, this is called household structure. So all of these variables represent socio-economic factors. Okay, you need to do this kind of survey, and then check. Okay, what is the distance from the city center? So, or the intensity, how often they need to do, and how much price they need to go. Yeah, friction here represent the price of the distance and the time. Okay, so all of these represent accessibility. Okay, and then of course the land use and activities. Yeah, so what is the land value? Okay, and then the residential density and so on. Yeah, so these are the input. Okay, the output. You need to, if you want to do regression, remember you need to get the both input and output, isn't it? Then you can correlate. So these are the input. Yeah, this trip generation factor are the input. The output is the person trips. Yeah, trip production or trip attraction. Is that clear or not? So that you will not get lost. So you need to do both. Yeah, you get the trip production attraction and then socio-economic factor, accessibility, and land use intensity, and so on. Okay, all of this data you need to gather in order to create trip generation model. Up to here, is there any question or not? The data, the input and the output. Okay. Next, let's talk about some simple model. Okay. In the past, there are a few proposed model. So we can use a simple growth model, cross classification, categorical analysis, or of course we have learned this already. So this is probably the best model, yeah, regression analysis. So, but remember, in all this model, you assume there are some causal relationship between the input and the output. Yeah? And then you also assume the model structure and the parameter are constant over time. Okay. So let's go to the first one, the simple growth. So this is very simple. Yeah. You just get the future factor and then the present factor, and then you multiply all the factor. Yeah. The advantage of this simple growth model is very simple, okay, but this is very rough, not necessarily correct. Okay, and then there are very important assumption that between factors they are actually independent. Okay, so let me give you example. Say you have auto trips here, okay, per day, which is based on the car ownership, fuel consumption, and daily workout. So these are the example. Okay. So these are the three variables that we put. And then you already know, okay, the base year, okay, and then you do forecast for the target year. Okay, this is the current year, and this is the forecast for the target year. Then we have auto trip today, say suppose 45,000. The question is, what will be the total auto trip per day in the target year? Okay, so remember, simple growth factor based on each factor, they are independent. So what you need to do is just divide. Okay, so the future divided by the present, and then you multiply. Yeah, and then the future trip is just the growth factor multiplied by the today's trip. So if you know that today's trip is 45,000, then you can get the future. Here this example. Okay, you have 34,500 divided by 23,000. Can you see this? This is the first factor, okay, with this car ownership. Okay, and then this is the second factor, fuel consumption, and this is the third factor with this number of worker, right? So then you divide, you get three numbers here. And then you multiply these three numbers, you will get the growth factor. Okay. Once you have this growth factor, you just multiply it with the current auto trips per day. Then you will get the estimate of the number of trips in the target year. Okay. Next, okay, the second trip generation method is called cross classification or categorical analysis. Okay, so yeah, this is the basically trip rate, yeah, but this is mainly home base. Okay, there are several table that you get, yeah, and then mainly home base, and then you assume, yeah, that the household can be classified into groups. And then the trait characteristic within this group is relatively equal, yeah, homogeneous, uniform. Okay, so the advantage of this simple model again involve interaction, not independent anymore between the factors. But okay, when the table become large, okay, when you include many factors, then there are many zero trip rate. So this is probably difficult to do. Yeah, and sometimes the selection of the factors can be unsystematic. Yeah? You can check there are some other technique we use log linear regression also, which is based on categorical analysis. Yeah, this is more reason based. So the computation is rather simple. We use Hadamard division and Hadamard product. Yeah. So dot divide is Hadamard division, and dot multiply, that means Hadamard product. That means element wise division and element wise product. Okay. So let's say you have the trips, percent trip rate, and then H here represent the household matrix in all zone. Then the R is the trip rate. Okay, and then you have the H here. It represents the estimate number of household matrix in the target year, and for zone I, for each zone. And then T is the estimate of total trip in the target year for zone I. Okay, so let's give examples so that you can get clear. Okay, suppose you had the survey. Okay, after you do the survey, okay, and you know the number of trips. Okay? Now, this survey based on the family size, the number of household, and the number of trips, and the car ownerships. Yeah. So we divide into three categories: 0, 1, and 2 or above. Yeah. So in that case, okay, you can get the trip rate simply by division. Can you see? So this one, yeah. The trip rate 1.19 is come from 1098 divided by 925. Okay. So this the number of trip divided by household. Yeah. So this one, the number of trip divided by the household. Okay. And then suppose you already know, okay, current year. This is the number of trips that you have. Okay. Supposed to have the same structure as the original trip rate. So this is the family size. Okay, this is again the number of car ownership. Okay, and this is the number of trips. Yeah, this one is the number of trips. Okay, then if you want to get the future trips, again you multiply, yeah, element wise. So if you get the trip rate, okay, table, then you multiply with the current. Okay, so 24 multiplied by 1.19, you will get 29. Okay. So this is another technique to get the estimation, yeah, of the if you know the trip rate, then you can get this. Yeah. Another idea, okay, is to check the socioeconomic factor, land use, and trip purpose, and then put it into this kind of chart. Okay. So, and then you will get the percentage of the person trips by trip purpose, and then you multiply that percentage with the zone population to estimate the person trips. So here is the chart. You will see in the curve A, okay, you will have the percentage of dwelling, and depends on the incomes and the number of car ownerships. Okay, so if you know the income and the car ownership, you get the percentage of dwelling units. Okay, so now in the second chart here, okay, again you have the income, and then you get the car ownerships. Okay, and then you will get the person trips per dwelling units. Okay, and then in the third chart here, again you have the income, and then this is the trip purpose. Okay, and then you will have the percentage of trips. Okay, so with that you can get the trip production by trip purpose. This is an estimate only. Yeah, by putting the vertical line to the charts and then horizontal line to the percentage estimate. Okay, so the best way is not using this table or this chart. Okay, This is historical reason. I just tell this. Okay, the best way is actually to use the linear regression a while ago. Yeah. So remember, the output is the trips, yeah, person trips. The input, many, yeah. So land use, socioeconomics, household structure, and so on a while ago. Okay, activities, okay, in the zone or in the household. Okay? And then you can do the regression. Okay. So, but remember, when you want to do regression, we have assumption, yeah, should not be violated, right? So the assumption is normally distributed. Say if you want to use multiple linear, so it must be linear, should be equal variance. A while ago, I asked you to Google this term. Okay. Oh, can you also Google this term? Multicollinearity. Yeah. So this is the one that I mentioned a while ago, that between X should not have high degree of correlation. Okay. Okay. So if they have some degree of correlation, then so you drop the X. Okay. And then the error must be independent. Okay. Should not be connected to each other. So otherwise you need to transform. Okay. So the advantage of multiple linear regression is simple, linear. Okay. So it can be extended to nonlinear, and the selection of factor you can do a stepwise. Okay, what is the stepwise regression? Check the t value. Okay, if the t value is bad, so you drop, and then you create the next model. Yeah, within the combination a while ago. Yeah, so that you can get the best model eventually. Yeah. So these are the example, typical regression model. Okay. All you need to see is the X and the Y. Yeah? The value should be calibrated for your case. Okay. And this is an example for zonal level or household level. Yeah. So look at this. The Y here is a person trips. Okay. Work trip by all mode per zone. Okay. And then the X here is represent this is the most important. So the number of dwelling unit, the number of worker, okay, number of motorcycles, and then the distance to the central area. Okay, on its zone. Okay, and here in this example of the regression model, again the Y is work trips per household, yeah, not per zone, but per household. And then this one is depend on the number of worker and the number of vehicles per household. Okay. Now this is interesting. The third model is interesting. You have the work trip per household as the output. Okay. And then now depends on certain dummy. Yeah, the X1 is the same here, number of worker. Okay. And then you have certain dummy variables, yeah, Z1 and Z2, okay, which depends on whether you own a car or not. Okay, so this is also one possibility. So JECA have example of regression model that they use for their software, right? Maybe JECA Strada. Okay. Which depends on the trip purpose, okay, whether they are using non-motorized or motorized, okay, and these are the factors, okay, of this simple linear model, yeah, and these are the variables, okay? And the second variable x2 is actually dummy, yeah, depends on the zone. Okay. Okay, up to here, is there any question? So you can use any model. So I'm suggesting if you want to use this, so you can use regression model. Okay. So some problem with trip generation model is actually space and time transferability. Okay. So whether the model structure will not change over time. Okay. Whether the model structure can be transferred to other cities or other countries, which of course they have different price, different culture, different policy, and so on. Okay. And these are the main problems. Okay. Look, they assume when we make the trip chain model, we assume the model structure does not change over time and space. Okay. But in reality, the lifestyle dynamically change, right? So there are certain improvement in the economy. There are certain new babies, probably children will go to school. There are certain people will leave the parent to go to the college, and some are divorced, dead, and retirement. And more people are joining the workforce for women. Okay. That some who own the car, that doesn't mean that they will use the car. So in this case, these are the problems that we assume does not change, but actually change. Okay. The same things with geographical or space transferability. Okay. So you need to be aware of these problems. Now, in summary, what did you learn today is regression model used for trip gen. Yeah. Trip generation is basically a model to relate land use activities with the trips. Okay. So with that, we end this model. So is there any question? Yes, Mark. Go ahead, Mark. Anthony, you want to say? I cannot hear you. I cannot hear you, Mark. Can anyone hear? No. Okay. So, Mark, you can type. No problem. Any question? Any comments? So what did you learn?
Hello, sir.
Yes, yes. Okay, I can hear you now.
Okay. So what I'm getting is that we're trying to, or you're trying to discuss to us how to model trip generation, right?
Correct.
But what I'm getting is that the procedure so far is very static, or yeah. So but however, in a real world, right, people's travel behaviors change over time due to a lot of factors. So how therefore can dynamic factors be considered in the model?
Very good.
Like for
Yeah.
yeah,
So,
and
and then,
yeah, basically that's a question. So how to consider the different dynamic factors?
okay. So, remember the big picture. We are in what is called classical, yeah, traditional transport planning. This is classical model. Okay. So next time I will discuss about IFN. Okay. So which is more dynamic. Okay. But this time we are in the traditional transfer planning with this classical model. So I need to give this because basically all transport modeling, they need to know about the old one before you go to the new one. Okay. So some people propose to make it more dynamic. in terms of trip gen. So one way is to do travel diary pattern a while ago. Okay, and then you can ask what time they are going. Okay, you need to make the survey more complete. Okay, in terms of what is the time they are going and time, what is the purpose, what they do, where is they come from, and what is the trip chain that they are doing. Based on that, you can start to create your own model, okay, which include the time.
Sure. Thank you, sir.
Yes. Okay. So the regression that I show a while ago is of course static, okay? But you can also include the time pattern if you want. Okay. Because once you know I can use regression, linear or non-linear, right? Then it's up to you to decide what variables. It's up to you to decide which factor you want to include in the model. Okay, as long as those factors represent the land use activity, socioeconomics, and the output is the person trips. Okay, so as simple as that. Remember, X and Y. What is the X? X must be land use activities. Yeah? And the Y must be trip production, trip attraction, which is trips, number of trips per person. Remember, still per person, yeah? Not per car. Okay. So, is it clear or not? The output, okay, is basically later on, yeah, OI and DJ, okay, which is the trip production and trip attraction in the table. Okay, so let me draw. Maybe I need to draw a whiteboard. Can you see my whiteboard? Can you see the whiteboard? Okay, let's draw this. So I have a table like this. So this is the origin. This is the destination. Okay. And here is the sum. Okay. Here is also the sum. Okay. So of course you have many rows and many columns in the table, right? So now this is the sum of origin, right? So this is OI, and this is the TJ. Okay. So trip generation will produce this one, the sum in that OT table. Okay, your model, say using regression, trip rate, whatever, okay, atau critical analysis, that will produce the origin and the destination for each zone, yeah, which is the sum. Okay, so this is zone 1, this is zone 2, and so on, okay, up to zone n, right? And this is, so for example, this is zone 1, zone 2, until zone m. Yeah. So the trip gen result, okay, is here. And the sum, yeah, this factor, okay, at the bottom and on the right. Is it clear? So for each zone, okay, how many will generate and how many will be attracted to that zone? Okay, this is the point. So then you ask, oh, how about the middle? Or how about the table itself? So from zone to zone, so this is called OD matrix, yeah? Origin destination matrix. So this is the job of the second step, which is trip distribution. Okay, so the first step is trip chain, is basically just to get this value, the sum. The second step is to get the trips. This is again person trip from one zone to another. Yeah. So OD table is from person trip from one zone to another zone. Remember, zone represent the district, yeah, or represent the barangay, probably. Okay. So where you have the socio-economic data. Suppose your zone is not exactly within the administrative boundary, then you need to assume uniformity in the distribution. So you can bet based on the area, and then how many of the area will be part of this zone, how many of the area will be part of the other zone, and so on. See, if the certain zone have no household at all, okay, say for example, CBD area, the central business district, that have no residential, in that case, the OI and that zone is 0. Yeah, remember the trip production is always home based. Yeah. Is this clear or not? Any other question? Specific scenario, is there any specific scenario where we can use regression? Yes, of course, you can use regression for this. So any scenario that you want. For example, you are doing what? Within your study area, okay, last time I do certain trips analysis of a new town, for example, okay, or a new shopping mall. Then you ask, okay, within the city boundary, okay, how many will be attracted to this new town or this mall? Okay. So you go using traffic impact assessment, right? So then you do zone based, for example. This is very simple, and then you conduct the survey, of course, right? So what is the survey about? The survey is a socio-economic factor, land use activities in the question, and then the trips also in the question. Yeah? Daily pattern in the question. Based on those two input, you put it into one model, which is trip chain model. Is it clear? Yeah. So once you have the trip chain, you can go to the trip distribution. Okay, so in the next slide is trip distribution. You go to model. Okay. If you go to model, you have the next slide is trip distribution. I put that after the midterm. Okay. Trip distribution. There. So trip distribution will not be included in the midterm, okay? Up to trip chain only. So let me share the trip distribution slide with you. So trip distribution is after the midterm. Yeah. So far we learned that transportation is the derived demand from activities, right? And then we also learn about simple demand supply. And we also learn about trip gen, which relate land use activities and travel. Okay. Now, in the trip distribution, okay, we want to connect the trip production, trip attraction available so that you can get what is called OD matrix. Okay, so remember, you have the table, right? And this is the OI, the sum. It is from trip gen. This is the DJ, okay? DJ from the this is the OI. Okay. Now OD matrix is basically this here, the cell here. Okay. So based on what? Based on cost, yeah. Based on friction, yeah. Depends on the cost, time, distance, yeah. Basically friction. We call this as generalized cost. Okay. So once you know the cost and the OI and DJ, which is the sum in the row and the column, then you can get the middle part. Okay, so calibration of this. There are several models, okay, that you can play later on. Yeah, we can do a gravity model, and we can use also solver of linear programming. Okay. Okay. So first part is what is called the friction itself, yeah, the generalized cost. So impedance or friction of the movement. So you go from one place A to B or from B to A. Yeah, there are some movement, but of course this movement have certain friction. Yeah, so friction represent either distance, cost, time, okay, safety, uncomfortability, and so on. So these are the example of value or factor that you can include in the generalized cost, yeah, represent the friction of movement. Okay, of course, so that you will have the cost in one unit, all right? Then this represent the gradient, yeah, or the slope between the cost and the unit of CIJ here. Yeah. For example, this represent cost in pesos. Okay, then this one must be the same unit, which is unitless, because this is already cost. But this one is the value of time, right? So how much cost per time? This one must be the value of distance. Yeah? How much cost per distance? This is supposed to be this A4 must be the value of safety. Right? How much pesos or US dollar per certain value of safety. Okay, safety can be scale, okay? Ordinal scale from 1 to 10, for example, or 1 to 100. Okay, then this represents the gradient. Is that clear? So you can also create based on speed, for example, yeah, with this function of the mode. Okay, so general factor can include anything. Yeah, these are the typical factor that you can use. Yes. Where will the forecasting of future year in the trip generation? Once you know the base year, you can forecast the future year, okay, based on any model that you want. Either you use regression, you use growth factor, or you can use any model that you want. Okay, so the current heavy planning model still use traffic growth. Oh, this is too simple. Okay, so at least you need to go using regression. Okay. So for trip distribution, you can use any factor, usually related to the impedance or the friction. Okay, so usually this is the policy variable: travel time, travel cost, terminal cost. Okay, but you can also include some qualitative factor, which is intangible. For example, comfortability, convenience, reliability. Okay, certain frequency, safety, security, and so on. Okay, these are ordinal scale, so you can put it as Likert scale if you want. Yes, 1 to 5 or 1 to 10, for example. So again, you need to do survey to create a model. Okay, so once you have, I think this is not important. Once you have the generalized cost, so in this case, example of generalized cost, I put it as distance, and this is represent customer, okay, of certain commercial area. Okay, then you will see the pattern. Okay, you start to see the pattern. Okay, so if they are convenience store, the blue one here, okay, the curve is like this. Okay, the number of customer will decrease, okay, sharply by the distance, okay, or by the cost, general cost. Yeah. Okay, if this is grocery store, okay, the curve is like this, the black one or the green one, yeah. And then if this is superstore, the mall, it will go in this kind of curve, you see. Okay. Of course, it will still go down with the distance, but at certain distance, they are still have certain values, up to certain values, and then drop drastically. Yeah. So the area under the curve, okay, represents the relative proportion of the people traveling for the farthest distance. So it means the convenience store customer are using short distance, right? For the grocery store, longer distance, okay, and then for the superstore or mall, usually short to long distance, and then suddenly drop here, okay, after certain distance. So in that case, we can model this, we can model this curve, okay, of general scopes, okay. So also we can create example of model. Okay. A while ago, we used this. Okay. Now you can put also the difference between distance and the cost, right? So you can, for example, if this is public transport, there are certain fixed costs. Okay, after certain distance, when the zone changes, it will go increase suddenly. Yeah. Okay. Or if the zone is actually very close to each other, so you can make it linear. Okay. Or there are certain increase, gradual, and then there is certain transfer costs. Yeah. Jump. Yeah. Or you can use nonlinear model. Okay. So now based on time and space diagram. So the space is based on distance and time. Suppose this is the transport time. Okay. Yeah. Then you will see certain range. Yeah. There are certain range in the time. Okay. And if the range is actually have different values, okay, then that range represents certain punctuality. Okay, and then if you put the time and space diagram like this, and there are certain transport time in linear like this, then you will see how frequent it happens. Okay, so now for this type of distance decay, we can put this into formula. Okay, so there is the formula, okay, that you can use. Okay, so the simplest is using power, okay, or you can include the power of exponent, or you can use a logistic model, or you can use more complete, yeah, with this power exponential model. Okay, and here is the typical value. Okay, I originally this is not color, so I color it manually so that you can see. Okay, so the red one is C exponent 2, yeah. Okay, and the next one is the plug. See, this is an exponent of -1 of the cos. The cos is here, and then this is almost linear going down. This one, okay. And when you increase the value to 0.3, okay, you will get this blue model. Okay, and when you put the power exponential here, okay, say for example this is square root 0.5 and then 0.1, then you will have behavior with change. First will go up, okay, and then later will go down, similar to this one, yeah, almost similar to the superstore. So yeah, so up to here, is there any question? So what we have discussed today, yeah, so spatial interaction will come discussed next week, yeah. So we have discussed regression, nonlinear or linear using matrix. We have discussed also trip generation. Trip generation is basically a model to relate the travel trip, yeah, person trips with any factor which is related to the land use activities. Okay, and we also discuss generalized cost, yeah, and beginning of trip distribution. So, one important factor of generalized cost is what is called value of time. Okay, value of time depends on the socio-economic. Okay. Those who has higher income, of course, the value of time is higher than those who has lower income, because the value of time is basically the income divided by the time, isn't it? So when they have a higher value of time, okay, then their behavior changes. Okay. So, for example, people who has a higher value of time, they are captive to private vehicles. Okay, and those who has a lower value of time, they are captive to public transport. Okay, so those are the meaning of this. So, is there any questions so far? Yes, Mark.
Sir, I tried to replicate the car price modeling a while ago, but I missed how the significance of variables is determined. Is how the p-value is determined. Is there a manual procedure or do we use the data analysis tool in Excel?
You can use data analysis tool in Excel.
Okay. So I tried to do the tool in Excel, but I'm getting I'm not getting the p-value.
You
Right.
don't get the p-value. Oh, okay. You want to share with me your.
Okay, let me share.
Mhm. Okay. You share it. Okay.
Okay. Can you see my
Yes. Oh, what
so here I don't know.
Oh, what is this 4,000 200. I think you make mistake. Why you have I think you make mistake in your data analysis because you have intercept and then you have the first variable and then you have second variable, yeah, and then you have the third variable, which is 4,200. Not correct. Maybe the way you input. If this is correct, the value must be similar to the computation a while ago.
No, let me check.
Can you see? Can you see your problem? Here.
Okay, let me just
Yeah.
review.
Yes. So this happened because p-value is like that because there are very high correlation between your output, which is the y, and you include also the y in your input. So highly correlated, you will get that. Yeah, this is very typical.
Sir, another question.
Yes.
For the exam next week, are we going to include or are the lectures tonight included in the
Yes,
coverage?
the lecture tonight included up to the trip generation. The trip distribution part is not.
Okay.
Okay. Okay, so thank you very much for today. And see you next week. We still have class, okay? So your exam is from morning until the class time. Okay, so see you then. Bye.